1,000 custom integrations. That's what you get when 20 AI apps, each needing their own connector to 50 different tools, custom auth, custom schema, and custom error handling for every single one. MCP collapses all of that into a single universal standard. With the 97 million downloads and major tech companies including OpenAI, Anthropic, Google, AWS, and Microsoft on board, this is one protocol to master. So in this video, I'll explain how MCP works and how to build one on AWS. Let's get started. MCP is everywhere right now. 97 million SDK downloads, 10,000 servers already live, and every major AI company has adopted it. Today, we are covering the M times N problem, the full architecture with three primitives, the complete AWS ecosystem, and how to build one. Let's dive in. MCP stands for Model Context Protocol, and it's a universal standard that lets AI applications connect with external tools and data sources seamlessly. Just as USB-C unified how devices connect, MCP is creating a standard way for AI to plug into any tool, any database, any cloud service. Today we're building our first MCP server on AWS from scratch. By the end of this session, you'll have a working MCP server on AWS and a deep understanding of the protocol. We're covering 6 key areas today, so let me walk you through the roadmap. First, the integration problem and why the M times N challenge was killing enterprise AI adoption. Then we'll deep dive into MCP architecture, covering hosts, clients, servers, the three primitives, and transport mechanisms. Next, the complete AWS MCP ecosystem, including EKS with 31 tools, ECS, Bedrock Agent Core, and infrastructure as code. Security is critical, so we'll cover IAM, SigV4, OAuth 2.1, and human-in-the-loop controls. We'll compare MCP with Google's A2A protocol so you understand where each fits. And finally, a live demo building your first MCP server on AWS. Let's start with the problem. Take a look at this architecture diagram. On the left, you see three AI applications, ChatGPT, Kiro, and Claude. These are the tools developers use every day to build AI-powered experiences. On the right, the services they need to connect to, Slack for messaging, GitHub for code repositories, and EKS for Kubernetes cluster management. Each of these services has its own API, its own authentication, its own data format. Now look at all those connection lines. Every AI app needs a custom integration to every service. 3 apps times 3 services equals 9 bespoke connectors, each with its own auth and schema. Scale this to 20 apps and 50 services, and you get 1,000 custom integrations. This is the problem MCP solves. Let's put numbers to this problem. With 20 AI applications and 50 tools, you're looking at potentially 1,000 custom integrations. Each one needs its own authentication flow, its own data schema, its own error handling. That's not scalable. That's technical debt at industrial scale. Here's what goes wrong in practice. Every model tool combination requires a dedicated connector, creating massive duplication across teams. Models are stuck with training data cutoffs, so they can't access real-time information. Without grounded, current context, AI models hallucinate more frequently. The key distinction to understand is this. Traditional APIs answer, how do I call this service? They're about the mechanics of integration. MCP answers a fundamentally different question. How can agents safely discover and use tools? It's about capability discovery and safety, not just plumbing. Now look at the same ecosystem after MCP. Same 3 AI apps, ChatGPT, Kiro, Claude, same 3 services, Slack, GitHub, EKS. But now each AI app implements one MCP client and each service implements one MCP server. The M times N problem becomes M+N. Instead of 9 custom integrations, you build 3 clients plus 3 servers, that's 6. Add a new AI app, 1 client, instant access to all services. Add a new service, 1 server, every AI app can use it immediately. That's what standardization delivers. So what exactly is MCP? MCP was created by Anthropic in November 2024 and is now governed by the Agentic AI Foundation under the Linux Foundation. This ensures open governance and vendor neutrality. OpenAI, Google Cloud, and Microsoft have all adopted it. Microsoft built it directly into Windows 11. The adoption numbers speak for themselves. 97 million monthly SDK downloads across Python and TypeScript. Over 10,000 public MCP servers already live in the ecosystem. Integration complexity drops from M times N to M+N. One protocol replaces thousands of custom integrations. One standard protocol replaces custom integrations between every tool and every AI model. Build the client once, build the server once, and everything just works. Let me show you where MCP fits in the bigger picture. We are looking at a 4-layer AI stack that builds progressively in complexity, and each layer depends on the one below it. And at the top, A2A enables multiple agents to coordinate and work together on complex problems that no single agent can handle alone. Layer 2 is AI agents, the execution layer that does the actual work. Agents make decisions and take actions autonomously based on what they learn. Layer 3 is MCP, which connects you to the tools and systems you need to actually accomplish tasks. Without MCP, your agent knows the answer but can't take action. At the foundation is RAG, Retrieval Augmented Generation. This grounds your answers in real data instead of stale training data. Each layer builds on the previous one. Grounded knowledge before tools, tools before agents, capable agents before collaboration. On the left is the MCP host. That's your AI application, in this case Kiro. The host manages the user experience, handles security consent, and decides when to invoke tools. It's the orchestration layer. It decides what needs to happen. In the middle is the MCP client communicating over JSON-RPC 2.0. Each client maintains a one-to-one connection with the server. It handles protocol negotiation, message routing, and capability discovery. On the right is the EKS MCP server. This is where capabilities live. It exposes tools like list pods and scale deploy, resources like config files, and prompts like troubleshoot. The server talks directly to the EKS API to execute real Kubernetes operations. Clean separation. Host decides, client connects, server delivers. Let's break down each layer. The host is the AI application your users interact with, like Claude Desktop, Kiro CLI, or Amazon Q Developer. It's responsible for managing user consent and enforcing security policies. The host creates and manages the MCP client instances. The client is the protocol broker. Each client maintains a one-to-one connection with one MCP server over JSON-RPC 2.0. During initialization, it negotiates capabilities, agreeing on what both sides support. It manages the entire session lifecycle, including session IDs. The server is where the actual capabilities live. It exposes tools, resources, and prompts to the client through a standardized interface. Servers can run locally via stdio or remotely via streamable HTTP. They are designed to be lightweight and focused on a specific domain, like EKS cluster management or GitHub operations. The key insight is separation of concerns. Host manages user experience, client handles protocol, server delivers capabilities. This three-layer design makes MCP composable and production ready. All right, quick checkpoint. So far, we have covered the architecture, three primitives, and the entire AWS ecosystem. Coming up next is the production security and how MCP compares with A2A. If you are building an enterprise AI system, are you going to start with MCP or A2A? Keep that in mind as we continue further. MCP servers expose three types of primitives, and understanding who controls each one is critical. First, tools are model control functions the AI can invoke to take action. You define them with the AirMCP.tool decorator, and type hints automatically generate the JSON schema. Tools require user approval before execution, which is your safety net for destructive operations. Second, resources are application controlled, read-only data identified by URI templates. The app decides when to load resources into context, not the model. No side effects, with live subscriptions for real-time updates. Resources are the context your app injects before the model resends. Third, prompts are user-controlled reusable templates surfaced as /commands. They guide the model towards specific workflows like troubleshooting or deployment. The user triggers them, not the AI. For transport, you have two options. Studio for local development, where the server runs as a sub-process communicating via std-in and std-out. And streamable HTTP for production, with HTTP post to a single eJoy MCP endpoint, SSE streaming, and stateful sessions via MCP session ID headers. Always use the same transport in development as you plan to use in production. AWS has gone all in on MCP as a founding contributor. 4 protocol features: elicitation, sampling, streamable HTTP, and tasks. Here's the complete landscape. For containers, the EKS MCP server has 31 tools covering the full Kubernetes lifecycle, available both locally and fully managed. The ECS MCP server handles the complete code to production pipeline with 7 read-only managed tools and direct inspect with Amazon Q console integration. Bedrock Agent Core provides the managed runtime with gateway, identity, memory, and observability for MCP servers at scale. The IIC MCP server has 9 tools for CDK and CloudFormation with validation, troubleshooting, and best practices guidance. The MCP proxy for AWS is your SigV4 authentication bridge, connecting std.io clients to remote streamable HTTP servers. It's GA and production ready. Amazon Q Developer and Kiro provide native MCP support across CLI, IDE, and console. Let me zoom into the EKS MCP server. This is the deep dive for Kubernetes practitioners. We've built 31 tools organized into 6 categories. Cluster management handles stack operations, insights, and VPC configuration. Kubernetes resources lets you apply YAML, manage resources, and generate manifests directly. Troubleshooting pulls pod logs, views Kubernetes events, and searches our troubleshooting knowledge base. Observability taps into CloudWatch logs and metrics with container insights integration for deep visibility. Documentation gives you real-time access to the latest EKS and AWS docs. The fully managed server runs with SigV4 authentication through MCP proxy. Every call logged in CloudTrail, and we're pulling enhanced insights from millions of clusters to improve responses. Here's the real power. Say deploy a Flask app to EKS and the AI handles everything, verifies the cluster, builds the image, pushes to ECR, generates the manifest, applies it, verifies pods, and checks logs. 0 manual CLI commands. That's MCP in action. Layer 1, authentication. Before anything happens, the system asks, who are you? Kiro's MCP client authenticates using SIG v4 or OAuth to reach the EKS hosted MCP server. Layer 2 authorization, and it has 3 tiers. Tier 1 IAM checks, can you use this MCP server? Tier 2 IAM checks, can you call AWS APIs? Tier 3 Kubernetes RBAC checks, what can you do inside the cluster? Layer 3 safety controls with human in the loop. For destructive operations, the system asks, are you sure? And requires human approval. If authorization is misconfigured, this layer catches it before damage is done. Layer 4 audit in CloudTrail. We record everything. Every request, every action, every decision. Regardless of what the other layers do, you always have a forensic trail. Security is table stakes for production MCP, so let's cover the 4 layers of defense in depth. First, layered IAM permissions. EKS requires 3 permission tiers. Invoke MAKP to connect, call read-only tool for read operations, and call privilege tool for writes. You need both MCP specific permissions and standard AWS service permissions. Both must pass. SIG v4 authentication signs every HTTP request with your AWS credentials, and it happens automatically through the MCP proxy. No long-lived credentials in your configuration, no passwords transmitted, just cryptographic signatures that expire in minutes. Auth 2.1 with PKC is mandatory for HTTP transports connecting to non-AWS servers. We support dynamic client registration and validate token audiences to prevent token misuse. PKC solves the problem that CLI apps can't keep secrets. The elicitation API enables human-in-the-loop controls. Before any destructive operation, the server pauses and asks for explicit confirmation. The AI cannot bypass this. It goes directly to the human. CloudTrail logs every tool invocation, tool name, parameters, caller identity, timestamp, and source IP. How does MCP compare to Google's A2A protocol? They're complementary, not competing. MCP is the capability layer, it's vertical. It defines how a single AI model connects down to its tools through the flow, agent to MCP client to MCP server to tool. Authentication, discovery, and schemas are all standardized. A2A is the communication layer. It's horizontal. It defines how independent agents talk to each other for task delegation and multi-agent handoffs. An orchestrator agent coordinates with specialist agents, each bringing their own expertise. Together they form the backbone of modern agentic architectures. MCP gives agents tools, A2A lets agents collaborate. Most enterprise failures aren't model failures, they're integration failures. MCP reduces tool integration chaos, A2A reduces coordination chaos. Getting started, begin with the MCP, you need tools before coordination. Now let's get hands-on. 0 to a production-ready MCP server in 4 steps. Step 1. Define your tools using the amcp.tool decorator in FastMCP. Type hints automatically generate JSON schema, so you write Python functions and the framework handles the protocol. Step 2. Test locally using MCP inspector on ports 6274 and 6277. You can test each tool individually with parameter validation before deploying anywhere. Step 3. Package your server as a Docker container and deploy to Agent Core runtime on AWS. Fully managed, no infrastructure headaches. Step 4. Connect any MCP client via streamable HTTP with SIG v4 authentication and your server is production ready. This is framework agnostic and model agnostic. It works with any AI client, any language, any deployment target. Let me switch to my terminal and show you. Let's recap the 4 things I want you to remember. First, MCP is the USB-C of AI, one universal protocol where any client connects to any server, reducing M times N custom integrations to M+N standard connections. Second, AWS is fully committed. 31 tools in our EKS server, 7 managed tools for ECS, Agent Core Runtime, IRC server, all open source and fully managed. We joined the MCP steering committee because this is production infrastructure, not experimental. Third, security is table stakes. I am SIG v4 OAuth 2.1 PKCE CloudTrail and least privilege. That is the only acceptable production posture. Fourth, tool design directly drives agent success rates. Workflow-oriented tools with input validation, circuit breakers, and observability make the difference between agents that work and agents that fail. Start building today. Everything you need is at github.com/AWS MCP 45 plus AWS service servers ready to use. Install MCP Inspector, configure Kiro CLI with EKS MCP, and review the spec at modelcontextprotocol.io. If this video helped you, subscribe for weekly deep dives on AWS Kubernetes and Gen AI. Drop a comment telling me which MCP topic you want me to cover next. 3 things to take away. Number 1, MCP is the USB-C of AI, one protocol that turns M times N to M+N. Number 2, AWS is all in with more than 45 MCP servers, all open source and production ready. Number 3, security is a table stakes. IAM, SIG v4, OAuth, and human in the loop is the baseline. See you in the next video.